Alright, this is my third time trying to make this video without getting interrupted by anybody. So, this is a ticket to your practice test, which means in order to get your practice test, you must get 100% on this assignment. If you watch the video, you will be able to. Or if you're just super smart, like some people, you definitely will be able to. If not, stay along and watch the video. Alright, so here's your equation. Y equals 3 times 1.5 to the x power. This is an exponential, which means it's in the form y equals a times b to the x power. B is always the number raised to the exponent. A is the y-intercept. So in our case, our y-intercept is 0, 3. And then we have to say if it's growth or decay. It is growth because the b value is 1.5. and 1.5 is greater than 1. You must explain why. So then to sketch, I will be checking to make sure you can plot your y-intercept at 0, 3. And then if it's growth, you go upwards with the curve. If it's decay, you go downwards with the curve. Day 2 is when we just evaluated our exponential equations. So here's our equation. All we do is substitute x in for x. So if x is 2, you're going to substitute 2 in for x. So 1.5 times 3 squared. You put that in on your calculator. You do a happy, happy, joy, joy. And you get 13.5. We don't need to round that because it's already a nice number. The next one is 2/10. So 1.5 times 3 to the 2/10 power equals 1.87 when you round that. So 1/8700. And last but certainly not least, 1.5 times 3 to the 20th power. Oh, jeepers creepers, that's a big number. Have no fear. Exponentials typically get very large and in charge. I actually did all of these in my head. Notice I didn't even pull up the calculator. Just smart like that, I guess. All right, so next one is a word problem. Don't freak out because you're still just evaluating. So shout out to Miss Young. Miss Young is having a baby. I forgot that she's going to have her baby in 2017, though, not 2016. So Miss Young's going to invest $200 at a bank that offers 5%, forgot the word, interest, compounded annually. The equation is y equals 200, because that's 200 is her y-intercept, times 1/500 to the x power. That's projecting the growth of her investment in y dollars in x years after 2016. So what will the value of her investment be in 2034? The first step you have to do is find x. To do that, you have to think how many years is 2034 after 2016? You could just subtract and realize that that is 18. Okay? So your x is going to equal 18. Your second step is to just plug and chug. So 200 times 1/500 to the 18th power is this. Now, we are in the real world here, people, so please label that in 2034, her investment will have gotten to be $481.32. Okay, moving to day 3, exponential regression, everybody's favorite. So you have this information. You can see about $1,000 worth of shares with the company, shows the investment over 10 years. So the first thing you have to do is realize what your L1 and your L2 is going to be. Typically your L1 is on the top or the left and your L2 is on the bottom. So you're going to find an exponential regression equation for the data, and you're going to round 2 decimal spots. So we want to get something that looks like this, because that's exponential. So you enter your, where'd my calculator go? Enter your data, and to do that you do stat edit. If you don't have an L1 or an L2, please let us know. And you enter your data. Close, clear, stat, edit, enter. Oh look, I magically have all my, no, I don't have my data in there, crap. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9, 10. Okay, and my L2 data. Is awkward silence. All right, got your data. Your next step is going to be to actually do the calculation. So here you hit stat, go over to calc, and you go down to 0, which is should be the EXP, exponential regression. And you don't have to get an R value, nothing fancy. So stat, over to calc, down to linear regression. I'm sorry, exponential regression. Exponential regression. And if you have this type of one, you can just go down to calculate, enter, enter. All right, so we're going to have to round our our A values. So look at the 3, does nothing to the 4, and our B values, look at the 5, it bumps the 4 up. So your equation is y equals 999 and 8400ths to the 1.05 x power. So that is just a model equation. Part 2, you have to find to the nearest dollar the value of the investment after 11 years. Well, since x represents years, we're just going to sub in 11 for x. Okay, and you should be getting $1,710.07. All right, day 5, you guys should be super duper good with day 5. So you will have the charts, you won't have to have it memorized. You're converting an exponential to a log and then finding the solution. So the goal with this is to find 5 to the what power equals 125. Now a lot of you guys freak out and are like, Miss Bailey, Miss Young, there's no A value. What do I do? Well, friends, there really is an A value. It's just 1, that invisible number that nobody remembers. So remember, if A is 1, you use that equation. So your log form would be log to the base 5 of 125 has to equal x. And what you would plug into your calculator would be the log of 125 divided by the log of 5. That's going to give us x. And whoop-de-doo, x equals 3, because guess what? 5 to the 3rd is 125. Imagine that. Your next one, and now you guys typically always ask, what's the B value? Remember, the B value is always raised to the exponent. So in this case, we have an A, which is 2. Just kidding, we have an A, that's 4. Even teachers make mistakes. B is 2, and C is 128. So we have to figure out 4 times 2 to the what power gets you to 128. Luckily we have our chart, log of 2 to the y over a is going to get us our x. And then what we plug into our calculator, wham bam, look at that, x equals dun, 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 5, because 4 times 2 to the 5th power is 128. All right, day 6, back to Miss Young. Now Miss Young is investing $200 at the bank that offers 5%, forgot the word interest again, compounded annually. There's your equation, y equals 200 times 1.5 to the x power, and that's projecting the growth of her investment. We want to know in what year. Notice, now it's asking for what year, so we're solving for x. Will her investment be worth $1,000? So all we have to do is take the $1,000 and set it equal to 200, and we have to solve for x. Luckily, we know that this is just a log, and you can convert the log in order to solve for x. So there's your y, your a, and your b. So x is going to equal, using your formula, this. Awkward silence again. And of course, you probably won't get a nice number, but I believe you get just kidding, 32.99. So, in 32.99 years, her investment will be worth $1,000. But what year is that? Well, you take 2016 and you add the 32.99 and you get, I'm going to go off the page, this, 2048.99. So what that means is in late 2048, her investment will be worth $1,000. All right, another Miss Young problem. So Miss Young, when her daughter is born, her hubby plans to deposit $500 into a trust fund that pays 6% interest compounded continuously. What will the balance of Miss Young's daughter's account be when she turns 18? So here is where the last little bit of information we learned, where we use E. We have this equation, PERT. PERT is one of my favorite equations, okay? Where A is what we're solving for. P is what you initially start with, so he's depositing $500 in. E is E. R is the rate, but it's the rate as a decimal. So 6% becomes 0.06 because you take 2 spots over. So R is 0.06. And then T is time, so since she's going to be 18, it's in years, so it's going to be 18. And then you literally just substitute in 500 E to the 0.06 times 18, and you should be getting this. So when Miss Young's daughter is 18 years old, if her hubby deposited $500 into this account, she would have that amount at the end of it. So please double check your answers. Make sure they're 100% so you can get your practice test and prepare for your real test next class.